sum this over the length that is given to me from A to B. So the length, that A to B, that length is the change in what? X. So X. This becomes an expression for volume. So that becomes an expression for volume. Now, if I have this an expression for volume, of course, I cannot integrate this when this variable is not the same as that. I cannot integrate y with respect to x straight away unless I get an expression for y in the form of x. Okay, and this is the expression for y. So v will then be equal to, in this case, v will then be equal to pi is constant, so to come out of this summation box, then we're going to have y squared. Our y squared, we put the equation there and square it, which is the same as pi integration of what? Integration of L squared plus x dx. That is, let me write it here. So volume will be equal to pi integration of x squared plus x dx. So that's it, which I've said the general equation is pi y squared dx. That will be the general equation. Right, so this will be volume. So at least we have an expression for volume, and then we have an expression for area. So that's, we have gone through the first principles of deriving them. So it should be, it gives you a kind of intuitive meaning into the illustrations that we've done so far. So that if you will not need to commit these into memory, you can think about it intuitively from first principles, then you get the same equations or expressions or formula. Right, so for volume, you'll be dealing with that, and then area, like we talked about initially, you use that for the area. Now when you're integrating, you must remember you integrate from one A to B. So your A to B must be there. So all you do is you integrate by putting A in, doing that for B. So the expression for B here, and then you subtract the expression for A to get your answer. So if it is 5 to 10, you put in 10 here to get the value, you subtract, you put 5 in to get your value, and then subtract to get your answer. And that is how it goes. So the limits will be given to you, and then it goes. Right. Of course, when you integrate, there's a constant c, but because you are going to subtract, the constant c's will cancel, and then that will get out of the equation. Then you come back to the basic equations to deal with. All right. So that is that for our calculus. I don't think there's anything more that we have not discussed. No. To the best of my knowledge, we have treated everything under calculus for this level. Of course, we have a little one or two things about that, about this that we are treating. But for this level, I think this is quite exhaustive. You can use this one for your studies. Right. The last bit that I'll add is, let's say sometimes you are given this, let's say this is a curve, and then you're asked to find this volume, this area. So all you do is that you must first find the area for this by using our formula. Find the area for all this. Okay. When you are done, then you know the area for this triangle. You can find it. So you subtract it from what you had, and then that gives. So sometimes you just have to look at the question and then do the manipulations. Okay. So other times too, let's say you have this, you have a curve that goes and that, another one that goes. Okay. You can be asked to find this area. So what you do is between this point and that point, you can find the area under this. Okay. Now if you want to find the area here, the area for this portion alone, Then if you want to find the area for this portion alone, then what you do is when you have found the area for everything from this top here to down, just find the area of this one, and subtract from the total. So to find the area for this one, you just use the curve here, the limit, use the limit to the limit given to find this one. So we subtract that one from the full one, and then it will give you this area. Right. So these are the principles that you use. Right. So thank you very much. Thank you. Now we'll look at the next chapter soon.